Good morning, everyone. So I will be discussing how small is nanoscale. So a nanoscale is super tiny. It's so small that you can see it with your eyes, even with a regular microscope. So compared sa pictures na nasa page 153, so mas malaki pa to compare sa nanoscale. So ganun kaliit yung nanoscale. So nanomaterials are things that are made really small, so small you need special tools to see them. So they can be tiny particles, tubes, wires, films, flakes, or shells. So scientists study them because they act differently at the size. For example, they can be stronger, lighter, or even more powerful than normal materials. So next is how to view nanomaterials. So, ordinary microscopes cannot visualize nanomaterials, so scientists use tools, special tools or special microscopes. So, the first one is electron microscopes. So, it was invented by Ernst Ruska and Max Knoll in 1930s. It They uses a beam of electrons instead of light to magnify objects up to 1,000,000 times. So, this offers much better resolution than light microscopes. So there is two main types of this, which is the scanning electron microscope, transmission electron microscope. Number two is atomic force microscope. So it was invented in 1986 by Gerd Benning, Calvin, and Christoph Weber. They uses a mechanical probe to scan and collect data from the surface of a material. Lastly is the scanning tunneling microscope. It was also invented in 1986 by Gerd Benning and Heinrich Rohrer. So it allows scientists to see and manipulate individual atoms and nanoscale particles. So this invention earned them the Nobel Prize in Physics. That's all.
Good day, everyone, especially to Ma'am Carido. I am Claire Butcon-Cuyag, a first-year BSBA Financial Management, and in this video, I'll be continuing the topic that was previously discussed by Ms. Gracie Bea Autor. In her presentation, we were introduced by the basic concept of nanotechnology, and in my report, I'll be focusing on the nanomanufacturing. So how we actually apply nanotechnology in the real world to create innovative products and materials. I'll be discussing the two main approaches, some of the key techniques used, and the impact nanomanufacturing has on different industries. So let's dive deeper into how science at the finest scale shaping our future. So what is nanomanufacturing? It refers to scaled-up, reliable, and cost-effective manufacturing of nanoscales, structures, devices, and systems. It also involves research, improvement, and incorporation of processes for the construction of materials. Therefore, nanomanufacturing leads to the development of new products and improved materials. There are two fundamental approaches to nanomanufacturing. It's bottom-up or top-down. So what is bottom-up fabrication? So it manufactures products by building them up from atomic and molecular scale components. However, this method can be time-consuming. Scientists and engineers are still in search for effective ways of putting up together molecular components that self-assemble and from the bottom up to organized structures. The second one is top-down fabrication. So it trims down large pieces of materials into nanoscale. This process needs larger amounts of materials and discards excess raw materials. So binali ni silang duha guys kay ang bottom-up fabrication kay murag itipo ang mga gagmay para makabuo og new product. And ang kaning top-down fabrication kay kuhaan ang dagko para bungkagon bitaw, and I mean naay mga dagko nga materials and imo siyang bungkagon para makahimo pud ka og bag-o nga product. There are new approaches to the assembly of nanomaterials based from the application of principles in top-down and bottom-up fabrication. These include deep pen lithography. So it is a method in which the tip of an atomic force microscope is dipped into a chemical fluid and then utilized to write on a surface, like an old-fashioned ink pen and tool paper. So the second one is self-assembly. It depicts an approach wherein a set of components join together to mold an organized structure in the absence of an outside direction. Next is chemical vapor deposition. It is a procedure wherein chemicals act in response to from very pure high performance films. So solid materials are deposited on a substance through chemical reaction. And next is nanoimprint lithography. It is a method of generating nanoscales attributes by stamping or printing them onto a surface. So it creates patterns by pressing a mold. Next is molecular beam epitaxy. It is one manner for depositing extremely controlled thin films. So it's thin film deposition used to grow high quality crystal films. So roll-to-roll processing, it is a high volume practice for constructing nanoscale on a roll of ultra thin plastic or metal. The last one is atomic layer epitaxy. So it is a means for laying down one atom thick layers on a surface. So with the use of these techniques, nanomaterials are made more durable, stronger, lighter, water repellent, ultraviolet, or infrared resistant. So the above mentioned characteristics lead to the manufacture of the present variety of nanotechnology, which enabled products such as tennis rackets and baseball bats to catalysts for purifying crude oil and ultra-sensitive recognition and classification of biological and chemical toxins. It is not impossible that in the near future, computers that are better, more efficient, with larger storage of memory, faster and energy saving will be developed. Soon, the entire memory of a computer will be saved in a single tiny chip. Moreover, nanotechnology has the potential to construct high-efficiency, low-cost batteries and solar cells. So to sum it all up, nanomanufacturing has two fundamental approaches, namely bottom-up or top-down, and it has also approaches deep pen lithography, self-assembly, chemical vapor deposition, nanoimprint lithography, molecular beam epitaxy, roll-to-roll processing, and atomic layer epitaxy. So that would be my report. Thank you.
Government funding for nanotechnology in different countries. Indirect government funding for nanotechnology is discussed as a key driver for research and development across different countries, such as United States, Japan, and members of the European Union heavily interested in nanotechnology due to its potential to revolutionize various industries from electronics to medicine. The paper notes that these investments reflect a strategic priority, viewing nanotechnology as vital to future economic growth and technological leadership.